Hello again. A lot of real world quantities have the property that their graphs shouldn't jump around. What do I mean by that? Well, suppose I created a graph, the time of day versus the temperature. And I'll put 1 p.m. there. And on the y-axis, I'll mark 75 and 95. And suppose I told you that the graph of the temperature function looks like this. Between 6 a.m. and 1 a.m., the temperature increases up to 75, and then at 1 p.m. it jumps up to 95. Just a sudden jump. 0.0000000001 seconds before 1 p.m. It was 75. Then that hand turns over and suddenly it's 95. Well, you'd probably say this is an unrealistic graph. This is not how temperature works in our experience, right? Temperatures can certainly increase quickly or they can drop quickly, but they can't increase like this. And what we have here is an example of a discontinuity. So we've started with discontinuities, but now let's go to continuity, the concept that was being violated in that previous example. F of x is called continuous at a value c if the limit as x approaches c of f of x equals f of c. Going up to this example, this equality is not satisfied at 1 p.m. That's because the limit as x approaches 1 p.m. of this temperature function does not exist. So if the limit doesn't exist, it certainly can't equal anything. Reviewing a little, the reason this limit doesn't exist is that the one-sided limits are different. The limit as we approach 1 from the left is 75. The limit as we approach 1 from the right is 95. So sometimes you see this definition of continuity broken into pieces. I mean, it's fine as it is, but sometimes you see it broken into kind of sub requirements. So for this equality to be satisfied, f of c must exist. The limit as x approaches c of f of x must exist, and the limit has to equal f of c. So continuity is really kind of the default. I mean, thinking about temperature, I mean, you would also, if instead of a temperature graph, we were graphing the height of a growing child or the height of a tree, you also wouldn't expect to see jumps like this. Having said that, a lot of people who take this class are business majors. And discontinuity, the failure of this condition, is more common in human created contexts. Suppose you are selling spice or something, spice online. You're selling time in bulk and it's $1.60 per ounce plus $5 shipping and handling. This is linear, because this is a constant rate, dollars per ounce. It looks like this, and it's continuous. There aren't any jumps. Now, suppose we wanted to encourage large orders. Free shipping on orders of 10 ounces or more. Here is the graph with the shipping and handling. Here is the graph if you didn't have to pay shipping and handling. And at 10 ounces, we go from having to pay shipping and handling to not having to pay shipping and handling. And you see the graph jump down as a result of that.